Hello everyone, in this video I want to show how to scrape data from website and the result should be in structured data structured. So I have this site here. I think this is an e-commerce website for bikes. As you can see, there's the name of the bike, there's the price, and what I want to get from this website is I want to get the components. So this is the component name that I want to get, and I think this is the features of the component. Uh, the first paragraph is the description, and then the specs. I think so like this one, travel or so there are a lot of components that we want to get from this site, and we want to have the result as a structured data, not unstructured data like JSON. Why sometimes we want to get the result as a structured data is because it is more easier to import to uh, relational database like MySQL or Postgres. So let's see how we do that. So this is the Python project I have. I think it's a simple project. Just name it Python project. So to get to parse the data from the website, uh, we will need the request libraries. Uh, After making our request, because we want to parse the data, we will use beautiful soup. Beautiful soup for um, let's make the script first. So there are actually three pages we want to scrape. The three kinds of bicycle, just pick them randomly, and each of them have a different components, of course, because they're different bicycle. And of course, the challenge is here is to put them into a structured database, a structured result. So usually, if you store the result in unstructured data, you usually use a JSON type of JSON type of format. So for instance, it's JSON. Okay. s- okay. Uh, it's very easy to store data in JSON because there's no rigid structures that you should follow. You can include components and just by setting. This is Post features. Features we can make an array again. Second first paragraph. So it's very easy because the structure is very flexible. So it's easy to store them in just a kind of type. But when you want to store it structurally, the challenge is because every bicycle have different components. So let's now for this size, there's only one tire. Uh, for this bicycle, it has two kinds of tire. It's also built for different from this bicycle because this is electric bikes, while the other two are mountain bikes. So the components are also very different. That's the challenge with studying the structure data. So what I would like to propose is there are the uh, two ways to do this. So so there are two ways to do this. You can make something like ID, product name, product price, and then make uh, in JSON constructor. You see that the result can be very nested. So components as an object and inside features there's a string again. So the structure is something to be nested. But if you want to do this structurally, uh, the first way is flat things out. That's the so let's file the file. So so, uh, s- features features one and frame features two. So you can flat them out. Okay. So it goes here. But the problem with this pattern is because there are a lot of components, your columns will be very wide. It will be very wide, very long uh, to the right. Okay, so what I want to do here is making two tables in quotes. So let's delete everything first. So let's say the first table is the second table is components. So say ID and task. So let's say Okay. Uh, this is the first table, and in this table you only store the, the main properties of the bicycle, like this. And in the second table, you store a component here. So my purpose is the troubleshooting like this. Okay. So, so uh, oh, that's nice. And you can have something like filters. If there are more, the most filters we have probably will be only three. So this is the ID of the product from here. So if the ID is one, that means the component is belong to this bicycle. Okay, so then here is this and the features. Okay, so I think this is a better way to store the data from this website structurally. So for the second component, uh, for the basic of ID one, the name will be this, and the features will be this. I think this is better because now we only have five columns, and there will be rows. There will be a lot of rows instead of a lot of columns, which will be easier to add if you want to import it to your database. Okay, this is the example for data. We'll see how we got it done. Example. So, so, okay. Now we know that to store the data structure, we want something like a table. In fact, we want two tables, and I think the perfect way to store them is using a CSV formatted file. Uh, So the result of the program, the harvested data should save as CSV, and I will use pandas data frame to export the data to CSV. So I will insert an additional library. Pandas. And now we have some pandas. So for the libraries for the quantity was from from so now as special use in data science project is what is here just to CSV. So first let's declare the URLs websites with the screen. Uh, that let's go down. Okay, we have our house. As you see before, we have two tables, right? So let's do ours then. So the tables. So we want to fill the ID per products. Uh, the IDs will start with five actually. So as we go through the URLs. So we look for its URLs. For URL, the URLs, we increment the ID first, and we declare a product object with the ID as the ID. And then we create a request and save the response. Response request get URL. So, response request. So what we do in this line is we pass the text of the response, the body of the response to beautiful soup. So the beautiful soup can parse text. So we'll find the name, the basic of course. Use the inspector element tool. This is the title we want. So let's see. H1 tag. This is the data that we want. So we get the class. And then so name soup find. We want to find the tag with these attributes which have this class. This. And then we get the tags and strip any white space and save it to the product object. Then let's get the price now. So, let's find the class. Oh, okay, this is class. Pass it here. That again. Let's make that space. So, okay. Now we will go through the components. Uh, so the components is categorized by sections. There's a frame section. This is a factory section. This is a break section. So first, we will get the parent of this section. As you can see, it is grouped by a section actually. I think this is one. Yes. So components is grouped like this. The second section is this, one, and so on. But the last one is not componentially. It is just an optional extras which the users can purchase. We don't want the last section. So we just want to get everything but the last one. So first, we should get the parent of all the section first. I think this is the one. Yeah. Oh, we can actually just get this. Let's try this first. So uh, sections brands. Now instead of saying find function. Use find all because there are a lot of the sections, not only one. So use find all. Find all returns a list. Uh, find only return a single object. So use this class here. Okay. Let's try creating this first. Let's render line instead. Okay. Pick for the first URL. Is it true? 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's correct. There are 8 of them. Okay. Uh, but remember that we don't want to use the last ones. It's not the company as equal actually. So use these three to get everything except the last one. So we'll look through the sections again. So section parent for in parents. Uh, Now inside the sections, multiple components again. Okay, let's see what the parents, how the data is represented. Okay, so inside this section, there are three components that we want. So we can use the same method again. We'll say so right type of it. And then after we get the components back, so it's and we will create a component object. In this component object, we store the ID of the product again. Actually, this will be a part of the components table here. And if you remember, we want to store the product ID in components table too. So we put the product ID here. Let's get the title. I'm sorry, I have a mistake here. We want to use section parents, and then find its descendants, not using the root. Sub is the root. We don't want to find this this text from the root, but only for this parent. Okay. Inside the component, we want to get the properties of the component. There are, I think this is the title, the name, and the features. So let's get the title first. Okay, this is the class. Nice. Right. Then we'll save the component object. Okay, it's actually it's an object. It's a dictionary. Uh, I got confused with the JavaScript notation of objects. In Python, it's actually a dictionary. Hmm. Component like that. The name. Okay, this is the class for the name. Right. Component name features. Since there can be multiple features like this one, this have three features. I think we should look again. So, okay, I think should get the parent feature first. Oh, okay. So for the name, it has this name, but for feature, it has this feature. The class is different. We can difference that. So let's say we have features. Parents. See, please find out. Right. That we look through the features. I don't want to use for each for this one. I want to use the standard for use friends because I want to get the number. We will see later why. We will do that. Then, okay. Um, FP, short for future parent. That's I. SF this to the component object. Components use formatted string. Features E plus 1. So there will be column features 1, features 2, features 3. Yes. Okay, I'll put it this way. And then after we get our feature set in the component dictionary, we want to save this component dictionary to the components table. Append component. I actually forgot to save the products here too, so we can review products. And so after this for loop run, the data will be populated here. The products data will save here, and the components of the products will be saved here. Now, what you need to do is save the data to CSV file. Okay, as I said before, Spanish for that. And this the this is correct. From now to CSV. I use capital letter. Component. Right. Let's try. Okay. This takes sometimes because uh, the bottleneck is in port connection, where to get to make a request and get a response, it takes sometimes. Then yeah, let's see. Product CSV. Okay, I think this is actually one of the necessary component. Okay, okay, we forgot to get the text. Silly. Okay, let's try it again. Since it's a project, I just do this like this. But if it's a big project, usually I want to set the data, the the response of each URL in catch file, so we don't have the bottleneck of making network request. Let's see. Okay, this is let's with Microsoft Excel. Okay, this is the product table. Nice. The, this column is inserted by pandas actually. This is the index. Uh, we can remove it by adding an argument to CSV function. But let's keep it like this for now. And the euro character is not is completely good. This is Microsoft Excel's problems because in our text editor we can see that it is correct actually. Yeah, let's see the components table. Okay, this is perfect. So the ID one is for the bicycle one. For this bicycle, this is this is all components. And we have the title, the name, and the features in these columns. So it's very neat because we don't have a very wide number of columns. Instead, we set them in rows. So because the data is structured, we have the possibility to do something like this. So we can compare the, the component for different bicycle. There's the bottom bracket first and bottom bracket two. The third bicycle don't have bottom bracket probably because it's an electric bike. Okay, this is very neat when you have a structured data like this. So hopefully, if you follow this video, you get the same results. Thank you for watching.